Okay, for this question we have to prove that the left side is equal to the right side. So what I'm going to do is I'm going to just manipulate my left side to equal to the right side, okay? So I'm going to rewrite the left side again, so that's going to be sine of theta over 1 minus cos of theta. And what I'm going to do is I'm going to treat it like a conjugate, so I'm going to multiply by the denominator but with a plus sign. So it'll be bracket 1 plus cos of theta over 1 plus cos of theta. And when we multiply that out, that's going to be sine 1 plus cos of theta over, and when we multiply the denominator out, that's going to give us 1 minus cos squared of theta. And if we recall our identity of sine squared theta plus cos squared theta is equal to 1, we know that 1 minus cos squared is going to be equal to sine squared. So we'll rewrite that again by replacing this as sine squared. So it'll be sine bracket 1 plus cos of theta over sine squared of theta. So it's going to cancel out the sine and the squared value. And what we get is 1 plus cos of theta over sine of theta, which is exactly equal to our right side. Therefore, we prove that the left side is equal to the right side. Okay, on this question is very similar to the question that we previously did, but we're using inverse trig functions. So what I'm going to do is, again, like the previous question, I'm going to prove that my left side, this left side, is going to be equal to the right side. So it's going to involve a little bit of algebra and a little bit of trig identities, I think. So let's give it a try. So cotangent is equal to cosine theta over sine of theta. And on the denominator, cosecant is equal to 1 over sine of theta minus 1. So what we want to do to this is multiply the numerator by 1 over sine theta plus 1. And likewise for the denominator, 1 over sine theta plus 1. And we'll multiply that out, so that will give us cos of theta over sine of theta bracket 1 over sine of theta plus 1. And the denominator, when we multiply these factors out, it's going to give us 1 over sine squared theta minus 1. And what I'm going to do is, before I do anything else, I'm going to get the common denominator for the denominator. So the numerator, I'm going to leave it as is. So that's still cos over sine of theta multiplied by 1 over sine of theta plus 1. However, on the denominator, that's going to give us, well, what I'm going to do is I'm multiplying this 1 by sine squared over sine squared. So that will give us 1 minus sine squared theta over sine squared theta. So now what I'm going to do is I'm going to convert this into a multiplication form. So what we're going to do is we're going to leave the numerator as is. So it's going to be cos of theta over sine of theta multiplied by 1 over sine of theta plus 1. However, on this next step, instead of dividing it by the denominator, we're going to multiply it by the reciprocal of the denominator, which will be sine squared theta over 1 minus sine squared theta. And before I do anything else, here's identity. So we know that 1 minus sine squared is equal to cos squared theta. So I'm going to cross that out and replace it with cos squared theta. Then we're going to simplify some terms, so we can cancel that cos squared out and cancel out that squared value. And here, cancel out the sine and cancel out the squared value. So when we write that out, that's going to give us, well, the sine theta multiplied by 1 over sine theta plus 1. Oops, and I also forgot cos in the bottom. So let me write that again. So that will give us, well, 1 over, in the brackets, well, let's do this one first. This one is sine over cos is tan theta multiplied by, well, 1 over sine theta is cosecant theta plus 1. And remember, the inverse of tan is cotangent. So if we put the cotangent theta down here, then we have cosecant plus 1, which is equal to our right side. So we prove that our left side is equal to the right side by using the inverse trig function of tan, which is cotangent, which belongs to the denominator. Therefore, cosecant plus 1 over cotangent theta.